let's go to this diagram. I think this diagram will be more helpful first. So this is a database selection strategy. That how do you select a database? So first you look at the data. That what kind of data do you have? If the data is structured, by structured we mean that there is a tight schema for the data. Then in that case, yes, the schema is required. In that case, you identify that do you need asset properties? Do you need transactional system? So let's take example of maybe a ticket booking system or a bank. So whenever you want to update the balance for an account or whenever you want to purchase a ticket, you want transactions. And and of course the schema is always fixed in those cases. So in that case, RDBMS becomes your choice, like MySQL, Postgre, Oracle. Now you say that you have a tight schema already, but you do not need transactions. Example could be product listing in e-commerce website. You know that for a product, there has to be some ID, product's name, description, color, variation, this kind of information. And a vendor is updating that information regularly. In that case, you do not need transaction because not many sellers are going to update the same product in the database. They all have their different products. So in that case, you do not need a transaction. So in that case, a document oriented database like MongoDB could be a good choice. Right? Again, repeating it. So when you have to select your database, first you look at the incoming data. Is it structured? So structured data means a tight schema is there. So you take the next step. Do you need asset properties? Is it a transactional system? Yes, then it is RDBMS. No, then you can go with a document-based database like MongoDB. Now you say that my data does not need to have a tight schema. Right. Then you do a further deep dive. Like what kind of data is this actually? Let's say your data is in blob format. It is an image, audio, video, right? Documents. Then in that case, you can go for object storage like S3 or Google Cloud Storage. Right. So we are talking about this part. This is not this. So we are talking about this part. Okay. Now you see that your data is in format of time series. So by time series data, it could be the metrics from your services coming like the CPU data, IOPS data, or it could be from IoT devices. In that case, you go for a time series database. Then your data is big data, right? Where a lot of bulky and batch queries will be run. So let's say you have all the tweets in last 24 hours, and then you want to analyze them and find out that what is the trending topic in those tweets, right? So this is huge data, this is big data. And if you are going to run some kind of analysis on them, then you need some kind of Hadoop or Spark jobs, right? So then comes the next section, data on which full text search queries will be run. Let's say you are building an e-commerce website and you have a lot of products like mobile phones, right? Apple, Samsung, a lot of mobile phones are there. And people are searching for a specific string. So you take that user's search string and you match it in your database with the product names. And this query, this matching does not need to be exact. Let's say somebody says mobile phone Samsung. Now in this case, your product name in databases Samsung, Samsung Note 9 mobile, right? Mobile. In that case also, so this is not an exact match, right? But still this matching has to work. So in that case, you will have Elasticsearch or Solar kind of database. And usually you don't make your Elasticsearch or Solar kind of databases a primary databases, right? So what happens is that, let's say the vendors, sellers, right? So it's a mobile phone vendor. Let's say Samsung is there. So Samsung will push information to Amazon, okay, that these are my product listings, store them. Then what Amazon will do, that Amazon will have some kind of primary database. And this primary database could be RDBMS or it could be some document oriented database also, or it could be NoSQL also for that matter. And then that information will publish to some queues, and then it will go to Elasticsearch or Solar, and all the search queries will come to this Elasticsearch database. Right. Then we come to the next part. Okay, that if my data is unstructured, if I'm flexible with the schema can change. In that case, the next question comes, do I need to run complex queries? Do I need to run some analytics query? Do I need to do some kind of joins also? Maybe I need to, maybe let's say I have two tables, customer table and accounts table, and I have to do a join on them. I have to rank them I have to rank them, I have to find maxima, minima, I have to do these complex queries, right? In that case, these columnar databases won't be useful. they will not allow such complex queries. So in that case, again, we can go to document-oriented database like MongoDB. Okay, I'm taking a pause here and please post your questions. And I'm going through the questions here. If it is an employee badge data and is access information in different buildings and levels, then we need a structured one. Which one will be better? Hmm. In this scenario, I don't think we need transactions because one badge can be carried by one person only. It won't be a shared badge. So by that logic, we can go for document oriented database. But let's say requirement also says that there could be some kind of shared badges. Let's say some kind of IT team, they have a shared badge, or maybe the temporary employees, they have some kind of shared badge, or guests, they can have some kind of shared badge. In that case, multiple people could be swiping their badge at the same place, but then it becomes a very complex use case, right? Because how do you identify that, okay, guest one is logging from which building, guest two is logging from which building? So I imagine in that case, simpler approach would be that I issue different badges to everyone. And in that case, I'll go for document database. And again, it depends on the scale also. Let's say you know that your company is a small company, the requirement is of work for a small company, and you know that for next 5 years also maximum you will have 10,000 or 50,000 employees, right? Then by all means go for RDBMS like MySQL, Postgres. These are famous databases. Everybody knows about them. Most developers are comfortable with them. So when you are choosing database, this is also important thing that you have to think about. That which database you are comfortable with. If your first choice should always be RDBMS because they are well established. There are a lot of helpful material available for them online. Most of the developers are comfortable with those. Yeah, RQD is required. Where I mentioned RQD. Okay, I'll correct the slide. Yeah. Thank you, Madhumita, for answering that. What's the difference between NoSQL and document-based database? So NoSQL, we will talk about it. There, we will cover that. Employee badge we have discussed. Yeah, for join Saparna, we have discussed, right? Yeah, here. Shilpa. Why should Elasticsearch not be primary DB? Yeah, Shilpa. So actually, there are a lot of uh, discussions around this. Like, honestly, I'm also not 100% sure about the exact answer here, but it seems that there is a flakiness about Elasticsearch. And that's why Elasticsearch company, they claim that yes, you can use Elasticsearch as primary database. But in my previous experiences, we have never used Elasticsearch as a primary database, and always the reason was that the trust is not there. But yeah, but there is no documented uh, reasoning about this. I'll again try to look into this. Do we use read heavy versus write heavy to determine database? Depend on you versus depend on you. See, if it is a read heavy system, in that cases, and yeah, so again, do I have a slide on this? Let me check. Actually, we have some use cases later on, Madhumita. I think we will cover in that. If it's still not covered, then we will come back to this question. Graph databases, Sai, are we will talk about them, but on a very at a very shallow level, because they are very niche databases. In my experience, I have not used them a lot, and I have not. I've given many interviews and I have taken many interviews, and I have never talked about graph database. Of course, if someone is going for that kind of team and if someone has experience on graph database a lot, then maybe uh, you, it could be a nice topic to be discussed. Right? But for practical interview scenario setup, graph database is a very niche topic. Yeah, so key value databases. So these columnar databases like Cassandra, DynamoDB, they are kind of key value databases only. There is another key value database like Redis, which is mostly used for cache. We will have some use cases and you will have more clarity later on. Where does Couchbase fits? I'm not sure, Vishal. Yeah, is MongoDB. So MongoDB, there is we have some previous slide which I skipped. We can go through them. Yeah, white columns name is columnar DB. If we need more write throughput, yes, I should require something like MongoDB by hand. Yeah, you can, Krishna, you can always go for handling transactions at application code level, and but it is a very, very complex thing. It's not a simple scenario. So if you in the interview, if you are saying that I will go about handling transaction at application code, then be ready to talk about distributed transactions and distributed logs and how would you manage them in at application level. If you have that if you have that expertise and knowledge, then do talk about it, because you will be able to showcase your solid backend experience in that case. But in most of the cases, you can always play with the choices of databases and you can get around that. Venkata, how DB's volume, performance, price relative? I don't think price and these things are usually talked about in an interview setup. And I also don't have knowledge about the prices, because there are a lot of offerings. They depend on a lot of things: what kind of servers you are running, what kind of cloud you are taking, what kind of support you are taking, enterprise, or you are taking this free version. There are a lot of things about prices. And volume and performance, again, like you can look at the benchmarks. Every database has a paper published on their benchmarks. You can look at them. But we will have some use cases where we can see that in what scenario, what database is more suitable. In okay, looking at Subodh's question, how to identify which particular database to be chosen? Example, NoSQL or DynamoDB. Okay. See, when you're talking about NoSQL, MongoDB or DynamoDB, see MongoDB and DynamoDB, as we have already seen, they're different databases. Right? So, like MongoDB, when you are using a document-oriented kind of database, like of course, MongoDB and DynamoDB, they all come under the umbrella of NoSQL, but NoSQL umbrella is very huge. So MongoDB specifically is a document database. And you can see in this flow chart in what scenario we are using document DB and and which in which scenario we are using DynamoDB. In RDBMS, MySQL or Oracle or SQL Server, again, they all are RDBMS at the end of the day. It uh, nobody is going to ask you in interview specifically that which particular database you are going to choose in RDBMS. And and in a practical setup, mostly you look at the what kind of database the teams are using in the company and what kind of expertise the developers have on a particular database, and that database is chosen. Generally, Oracle is very expensive now, so MySQL and Postgre are more popular. Elasticsearch again is a very different database where you have when you are running search queries, then you are using Elasticsearch. And Memcache and Redis are usually your in-memory caching systems. And you can go for Memcache or Redis, any one of them, but Redis is more popular and nowadays. Yeah, and again for Memcache, the distributed setup is actually quite complex compared to Redis. So when you start your applications at a smaller level and you need a caching system out of the box, then even one server of Redis is quite scalable. So that's why people go for Redis. And in earlier cases, when there was no concept of distributed Redis, at that time, people used to go for Memcached because they wanted a system where you could have many servers to serve the caching request. But now Redis has a distributed flavor as well. One case where I see Memcached could be useful is the one. Let's say you have lot of let's say you have lot of application servers, right? And let's say they all have 16 GB of RAM, and you do the profiling and you see that you are using only 4 GB RAM out of that. Your application, that microservice that you are running, it uses maximum 4 GB of RAM. So that means 12 GB of RAM is still lying idle. And let's say this is 12 GB and let's say you have 100 servers. That means what? 1.2, around 1.2 TB of RAM is lying idle. In that case, what you can do is that you can have Memcached binary also running on these application servers. So Memcached will have its own cluster, and then you can allot maybe let's say some 8 GB or 10 GB. You won't be using the 12 GB completely, you have to leave some buffer. Let's say you use 8 GB. So you give 8 GB to Memcached. So that means you have 800 GB of distributed cache without any extra cost. Be- Now, in case if you would have gone for Redis, in that case, you would have to have different servers for Redis, and that would have added extra cost. Without adding extra cost, Memcached can help you better. Yeah. So in this case, you will go for Memcached and not for Redis. Yeah, Pallavi. So for these open TSDB and these things, no, these are again very niche databases. If you have experience about them, then you can talk about them. Okay, Alka, you want me to repeat about Memcached and Redis? Okay, sure. Let's say you have 100 application servers, right? Like this. You have 100 application servers, and each server has 16 gigs of RAM. And your application, your microservice, is using only 4 GB out of that. That means 12 GB of RAM is idle. It is free. And if you do a calculation, 12 GB on each server and 100 servers are there. That means you have around 1.2 TB of idle RAM. And let's say you have to add a caching layer before your application service, right? Let's say we have to add a caching layer here. One choice is we go for Redis. In that case, what happens is that Redis will run on their own set of servers. Right? So that means you add extra cost here. And these Redis servers are quite expensive because they are optimized for RAM and they need to have a huge chunk of RAM. So these are expensive servers. So this is extra cost and expensive. What if you could use this 12 GB of idle RAM? In that case, Memcached comes into the picture. So what you can do is that you can run Memcached as an executable, as a binary on your existing application servers. And you can allot, let's say 8 GB out of this 12 GB. So you can allot 8 GB to each of the Memcached binary. And all of these together, they form the distributed caching layer. So you have a fully functional distributed caching layer without adding any extra cost. We can scale RDBMS also when the user increases. Yes, RDBMS we can scale, we can vertically scale. Horizontally, we cannot scale. And for that reason, now we have distributed sequels like Cockroach DB, Yugabyte DB, Spanner. Yeah. What is the meaning use case of white column? So white column databases and columnar databases are similar actually. So when the term columnar came, that means it's a column oriented database. Right? So, and again, column oriented, what is column oriented database? What is row oriented database? This has been covered by Omkar in the fundamental system designs. So I'm not going to repeat on that. I'm just going to say what is columnar and what is white column. So when these databases came into existence, earlier they used to have only limited set of columns. So for each key, they used to have columns. Start a new page. So for each key, they used to have columns, and earlier the number of columns were limited. I'm not sure about the exact numbers, but I think it was a small number. At that time, they were called as column-oriented columnar databases. And then the next versions and next releases of these databases started support for hundreds of columns. That for each column you can have hundreds of columns. And at that time, the terminology wide column database came into picture because you can have this wide number of columns. For key value storage, is RDBMS is the best choice. For key value storage, Redis and NoSQL and databases like columnar databases are the best choices. Yes, you can use RDBMS also for key value storage. It is perfectly possible, but again, for scalability, it won't be a good choice. Yes, Sankalp. So in that case, you will have to take screenshot of your in-memory data, and you will keep on saving it to in the disk. And when that particular server crashes down and when it boots up, at that time it will reload the data from the disk and put it in the RAM. And this concept, Sankalp, is used by Cassandra also. So if you go through the Cassandra architecture, this will be super clear for you. Can RDBMS used in distributed system usually? Yeah, so RDBMS, when your system is, yes, exactly. So when you want horizontal scaling, when you hit scaling limits, at that time for RDBMS, if you have to go with the RDBMS, in that case, you first go for the sharding option. So RDBMS has something which no other database in the world has. RDBMS, they give you transactions, they give you asset property. No other database can give these things. So if your application, your service says that I need to have transactions and asset, you can't go for NoSQL database, right? So you try vertical scaling. At one point you say that, okay, vertical scaling is not an option now. Then you see that, okay, how can I use sharding here? But again, sharding comes with challenges that distributed transactions are not possible. Then how do you come up with a smart sharding strategy that you are still able to do transactions? Right? But this class is about choosing the database. It's not about sharding. So I'll, I'll not cover on that aspect. Why will a NoSQL database outperform a sharded replicated RDBMS with a cluster index? So Irfan, I'll just answer briefly because we have to ask. So because the problem with RDBMS is comes in the constraints, and so you have lot of constraints, then you have lot of indexes, and then there is a lot of things related to the architecture. that in RDBMS, lot of disk writes are done. So because of all these things, a write in RDBMS is expensive. When you talk about the NoSQL databases, usually they do not have constraints. The number of indexes are smaller. And another important thing is that in NoSQL databases, first the writes are done in RAM, and then periodically those things are flushed to the disk. So that kind of architecture decision makes columnar databases very efficient. Again, again, sorry about the same thing. If you read about the Cassandra architecture, this thing will become clear. And maybe I think, yeah, I think I'll see if we can have a Cassandra architecture class next time. It will be useful. What are constraints? These are related to RDBMS, Shri. You can Google it. Sorry. Could you please provide an example where columnar DBs like Cassandra are a good choice? Yes, we will talk about it. Abhar. Is it preferred to have multiple DBs for an application, not even for transaction? Yes, we will look into that. I have lot of uh, if you see, we are still at 25 slide. We have 47 slides. I have a lot of hands-on slides. So let's move fast. Asim, let's park your question if it's not blocking you right now. If it is blocking you, please raise your hand. If it's not blocking you, maybe we can take it at the end because we still have so many slides and so many good things to cover. Again, this is the same thing repeated which we discussed earlier. That so you can look at this table later on.
Want to become a software engineer at Google? You can, like thousands of our students. You just need to learn from those who've already cleared FANG interviews. At Interview Kickstart, our interview prep courses are developed and taught live by 150 plus instructors from Tier 1 companies like Google and Facebook. Our courses are tailored to help you crack software engineering domain interviews, including back-end, full stack, machine learning, embedded systems, data science, and more. To learn more, book your 3 webinar slot today